So I'm going to share with you a few new resources and maybe a slightly different method you're going to go through. In Chapter 5, I put a solution video for the Chapter 5 homework quiz. And so we're going to kind of flip it. Instead of doing the homework first, you do the homework quiz first by watching the video. And I work through each of the 6 or 8 questions that are in that homework quiz. Now, your questions are going to be a little different. Usually the numbers are different, but they're the same questions. So if you watch the video, you'll see how to do them, and then you just have to work yours with the numbers that you're given. Occasionally, students will be watching the video at the same time, and they start using my numbers instead of their numbers, and then they get it wrong. They say, I got it wrong. I said, well, you used my numbers, not the ones in your question. So we'll kind of do that. But what that will do, and this is what I did when I was at Scottsdale Community College, is it gets you basically know the I guess the most important ones. Then when you go back to the homework, there will be more practice with those types of questions. Okay, and so you'll see the methods for solving them. Okay, and I went back and I went to Chapter 4 and I did the same thing. So there's a solution video for homework quiz number 4. Now, if you've already done that, you don't have to go back and do it again, right? But it's there. So there's a solution video. It's in YouTube, and you can see exactly how. Wow, that was fast. So you'll be able to see exactly how to work through them and get caught up on the homework quizzes. And then there's the homework, and then there's the reading quiz, which a lot of you are getting through those. Some are not. We'll talk about that today. But the reading quizzes should be from the notes and everything, and just kind of help you solidify things. And what the goal is, the reason I'm not super strict on a deadline of you have to have it done by this is because the deadline really is each exam. So the next exam, the full exam we have, will be over chapters 4, 5, and 6, right? So you have to have it done by then, but pace yourself so you're not trying to get them all done the night before the exam or even the week of, because that's going to be 3 or 4 weeks worth of work. Okay. I've worked with junior and seniors in college, and they have as much problems with time management as anyone else. And I've got students who will wait till that last week before the exam. But remember, if you don't do well on the exam, that's the biggest part of your grade in college. So the goal is to learn the stuff, do well on the exam. And that's why they're not always so strict on particular due dates. You do have to get it done. But so as soon as we cover a section in class, it's good to start working in it. So we'll get doing that today. And as I mentioned, once we finish up today, we will have all of Chapter 5 done kind of half day early. So then we can work on it. You got Thursday, and then what we'll do on Fridays, we'll do a practice test over this unit on probability distributions, binomial distributions. So then you start seeing the types of questions that are there that'll be on the exam. Okay. What I'd like to do today is, then once we finish this, I'd like to do little check-in conferences. So I've got a little two tables set up over here. I'll call people over, and then someone will come and we'll just see how you're doing in class. If you can think of 2 things, what's going well for you, what's working well, what am I doing that's doing well, what do you like about the class, and what could we do to improve things for you on a personal level. Maybe I stand in the wrong place. Maybe I don't smile enough. I don't know. So anything that you come up with, but just think of 2 things. Sometimes you might say, oh, I don't know, but I want to make your experience in learning enjoyable, because the more you enjoy something, the more you do it, and the deeper you'll learn it. In fact, in Thailand, where I've done some work, they have they call it plearning, for play learning. And they have a lot of their colleges work on this, is to make learning fun, because the belief is, and the research shows, if you're having fun, especially younger kids, but hey, we all want to have fun, right? The more time we have fun, the more we'll engage with it, the deeper we'll learn, and the more we'll do. So kind of a different approach, but I like it. Okay, So then what you'll see, and hopefully have been seeing, is in the learning objectives is where I've been putting the items. So there's the PowerPoints or the Google Slides that I use, and then there's a link to the recording for what we do in class. And so notice from 5.2, which we did, there is the recordings already here. There will be one more recording of what I'm doing right now. And again, we'll try to get it done maybe the next 10 minutes. And those are helpful because I do show how to use the calculator. I find for me, if I'm watching someone do the calculator, it's hard. And I get off a little bit. But if I had a video, I can go back and I can pause it. I can go back and see what key did they press. So that's why I do those things. Okay. Any questions yet? Okay. So we're going to come to this part of the slide show. Let me out of full screen. Let's go ahead and start it. So we're going to look at an example. I'm going to show you, remind you how to use the, the distribution tool in here to come up with the values. We're then going to actually see how once those are in there, we can make a histogram from it. The calculator will do that, as well as coming up with the mean and the standard deviation. The calculator can do that too. Okay, so we're going to take this as our example. I don't think we did this yesterday, did we? Did it look familiar? No, maybe not. Okay, good. Okay, so we read through here, 64% of people. Now, when you see the word percent, what's that usually going to tell us? We're doing probability, and when we see percent, what do we want? What do we think of a percent? That's a chance. That's the probability that we're probably going to use somewhere, right? This one, they got a little tricky. They didn't do it as a number, so sometimes you don't see it, but I'll just write it there. 64% of people who have survived cancer are ages 65 or older. You randomly select 6 people. So again, it's not written as a number. Maybe we do that, so that might be important. Who have survived cancer, and ask them whether they are 65 years of age or older. Construct a probability distribution for the random variable x. Now, how do we know this is a binomial? There's 2 main things a binomial needs. Success or failure, right? A yes or no. And isn't that what the question is? Is are you 65 or are you not, right? Or it's older than 65. So it's a yes or no question, right? So success, failure, that fits. What's the other thing a binomial needs? Something about the probability. Can the probability change from trial to trial? No, not with binomial. If it is changing, then it's not binomial. Okay, so the binomial, we can't have changing probabilities. So the 64%, since that's kind of that's from the population, right? We're going to assume that that never changes. We pick 6 people, and they each have a 64% chance of answering yes, they're 65 years or older. And they have a 64% of saying yes. What would be the probability they say no? 36, right? Take it away from 100. So what we just determined here, this is our p-value. We also calculated our q, which we see with our tool that we need. We don't need this as much, but that's the 36%, right? So these two have to add to 100. We have the value of how many people we have, how many trials, that it's 6 people, right? And then they want to construct a probability distribution for the random variable x. What are the possible values for x? X is the number of people who say yes, I'm 65 or older. So we have, could 7 people say yes, I'm 65 or older? No, because there's only 6, right? So 0, 1, 2, but 0 could say it. They could all be younger. So these are the values we get. And so they want us to find all the values from 1 to 3 and so forth, all the way to 6. I'm going to, well, let's do 1 just as a reminder so that it's here. How do we find these values? We go and in our calculators, and if you have your calculator out and want to follow along, great. If you want to watch the video later, that's also good too. But we go to distributions, we hit OK. And notice all the distributions we have. What we're going to see is next week when we get into the next chapter, we're doing a different type of distribution, but we'll still be using the same tool, which is kind of cool. Once we get used to this, then whole next chapter is going to be similar too. So we're doing binomial, so we could hit OK. It asks us what is the value of n. Okay, that's 6. And then what is the value of p, which is the probability of a success. That's 64. So it's actually 0.64, right? We'd use the decimals. Go to next. And now we can, actually it gives us a sort of a graph of what's going on. What we have to select is, if we go to the left arrow and sort of go down, we get all these icons. There's 4 different types of calculations we can do. We can either look for the percent that's below a value, the percent that's between 2 values, that's the next one, or the percent that's above a value. See, all of those. Or the last one is the one we want, the percent that are at a particular value. Notice it's just a single line there. And so if we go down to that and hit OK, we're going to get x equals a particular value. And why don't we go ahead and, so we're going to do a 0, 1, 2, 3. We have to do this 6 times, but that's not too bad. We just hit OK. Actually, it's already calculated. For 0, it's going to be 0.002. So that's less than 1% chance, right? Let's just go ahead and do, I think, let's see, if I go up there and I go over, oops. I guess I have to, I hit OK. There we go. And now if I go over, if I put in 1, that's going to be 0.023. Okay, so 2%, 2.3%. So I can calculate them all, and I would keep doing this. I would change it to 2, and then I get my value. I write that down. I'm going to stop there because, again, that's something you're going to be doing with some of these. They did it and put it in our presentation slides. So notice this is what we got for 0. It was 0.002. Notice this is exactly what we got for 1. It's 0.023. They're doing it to 3 decimal places. If we would have put in 2, while we're here, it's easy enough, right? Put in 2, and it's the 0.103. So we could feel pretty confident as we put in each of these values, we would get each of these. Okay, so we need that's one of the skills we need, right? What I want to do now is I want to turn this, though, into an actual histogram. And for that, we're going to go back and do something we've already done. What are we going to do? Let's go back to the main screen. For that, we're actually going to go up to our statistics. Remember, we put in values, and we could actually do histograms and calculate standard deviations and means, right? So we did that under statistics, and we get this. Now, if you have anything in here, you can clear it out. I believe you just hit the clear and the execute. If not, we'll work on that. But this is we put in our V1, our values, and then we put the frequency. So what the value, the V1 is going to be, it's going to be our random variable, 1 through 6. So actually, I'm just going to go ahead and enter 0, enter, execute 1, execute 2, execute 3, 4, 5, and 6. And I do that because then it's easier to come back. It just, you could have been doing this all along, but then for the frequency, we're going to put in its probability, right, or its percentage. So 0.002. And we won't have to actually do that this much. I just want to do it so that you can see that the formulas we're going to come up with, or that they give us, are all going to work. So 0.103, this time we'll put everything in there, 0.245, 0.326, 0.232, and then 0.069. So about 6.9% for that last one. And again, remember, what are the values of x that we're having? 0, 1, 2, 3, 4, 5, 6. If the number is 6, what did that mean? 6 people said, yes, I'm over 65. If it said 4, it means 4 people said, yes, I'm over 65. 2 people were not over 65. So kind of always tie it back to what we're doing with it. Now remember here, if we want to look at the graph, we just arrow up. Now that we've got our frequency table in there, and really what we've put in is relative frequencies. So we did this earlier in the class. We go to graph, and we can select the type. We want to do a histogram. So that's the first one. We'll say OK. And notice we get this nice little histogram. And over here, that's what they did too. So we can kind of replicate things. By looking at that histogram, remembering mean, median, mode, what could you tell me just from the histogram about the mode? Four is the largest. It happened the most. That's our mode. Does this look skewed or symmetric? It's a slight skew, but it's not really skewed like some of the ones we've seen, right? But yes, it has a little bit of a skew. It's not completely symmetric, but if we maybe got rid of the 1, it's a little bit closer. It's not bad, but it's not perfect, right? So if you had to estimate, what would you say is about the median? What would be the middle, not the mode, but the median or the mean? About 4, right? Maybe maybe a little less than 4 because of the skew, right? Yeah, so somewhere in there, right? About 4. So what we're going to do is we're actually going to calculate it with our calculators and see what it is. It will tell us, and we'll see, yeah, it matches the picture pretty well. How do we get that mean? Remember, we go up here and we go over to our stats. When we hit that, it's going to do all the calculations from that table we set up, and it gives us one thing I would change on this calculator. It gives us all the median and the 5-number summary first. Usually we don't use that as much. Bless you. I was just talking about allergies this morning, because from when I was in Oregon, I had a lot of allergies. I moved to Arizona. I didn't have them for a couple of years, and then I got a lot of allergies. I moved here. I don't have them yet, but I find maybe in a couple of years I might start getting allergic to, because you guys got a lot of good flowers here, right? Anyway, life, right? And I love the flowers coming up. So then the mean is 3.84. Does that make sense with that picture that we got? Yeah, we said it's almost 4. It would make sense. And a slight skew would probably pull it back over the other way. But the cool part is we also get the standard deviation here, 1.17. Okay. Now that was a lot of work though to get a median or a mean and a standard deviation, wasn't it? We had to actually calculate each of the probabilities. We had to put them in the table, and then we had to come over here and do the calculation. I mean, it was a bit. Wouldn't it be nice if there was a simpler formula? Of course it would be. So what we're going to do is we're going to see, what I want to compare is there is this formula. Histogram, you can see that would be unusual for anyone, for none or only one of the survivors to be age 65 years or older. So yeah, so if we look for unusual values, yeah, probably here these would be unusual. Everything else is kind of within usual. But here's the formulas that will work, and let's test it out. So the mean, all you have to do is you have to take your value for n times p. So let's do that. Our value for n was 6. What was our value for p? 0.64. So Could somebody with a calculator calculate 6 times 0.64 for us? Because I want to leave my calculator up here. 3.84. Is there another decimal? No? We got 3.842. So yeah, we got maybe a little bit more accuracy, but we got the same mean, didn't we? We got the same mean. So this works. Wouldn't that be nicer if we already knew n, we knew p? If you just multiply them, you're going to get the mean. Okay. This would be a nice thing here to like put in the notes that you use for your test. Because this only applies to the binomial. What we're going to see is each distribution has slightly different formulas for calculating. So you want to list them by distribution. So if it is a binomial, we can do this, this, and this. But next week, we're going to do the normal distribution. We'll have some different formulas for those types of formulas. Now the variance, do we ever use the variance? I don't remember using it, do I? The only thing we use it for is to get the standard deviation. We take its square root. So I'm not even going to worry about this one. Again, it does get used in more advanced stuff, but even then, it's not used a lot. So it does have a purpose, like if you're into real specialized stuff. But for most of us, most research, all we need is a standard deviation. So this is the other one I would have. And let's have somebody do this. Can you calculate the square root? N is 6. What is p again? 0.64. Now we need the q value, which is the probability of a failure. And we did that one. Subtract it from 100%, right? Take away 64%. We got the 36%, 0.36. Now watch, when we multiply these three numbers and take its square root, what do we get? 1.17. And look up in our little calculator here. It's kind of small, but it's 1.17. Exactly the same thing. So instead of having to go through this whole process, we got a nice little formulas going to give us answers right away. So notice, when it's easier to use the tool, we go ahead and use that, but sometimes it's easier to use the formulas. So let's kind of go through here. And most of my mathematical research is I've looked at the mathematics from India. And I may have said this before, but part of that I have an adopted brother from Thailand. So I started, and the way he wrote his numbers were different. They have different, but 0 through 9, they have a special script that they use. And so I thought Thailand invented their own math. Well, when I got looking, those scripts come from India, a southern school of India. The northern school of India sent their mathematics to Europe. So we write our numbers differently, but the math is really the same. Where was I going with this? Oh, in India, what they did is they looked at different ways to do math, and they would have multiple ways to solve problems. And depending upon what the numbers were, sometimes this way was easier, they would use that. If another way was easier with a different set of numbers, they would do that. And so I take that same approach, is let's find the easier way to do it and maybe look at both of them, but which one are we going to use? The one that's easier, the one we enjoy a little bit more. So we show you both, and that's it. Okay, so this is pretty much the end of the road. Here's another example. We won't go through all of this, but what they're going to do, I'll just show you in the next slide. They actually apply those formulas. 56% of the days are cloudy. Find the mean, the variance, and the standard deviation. Again, the two that we're interested in is the mean and the standard deviation. And so what are they going to do? They want to find cloudy days during the month of June. Okay, so again, 56% is the year-round numbers. And so 30 days in June, probability of success of cloudy is a 0.56, probability of not cloudy, 0.44. So to the mean, they just take the 30 times 0.56, and they get that. Notice they didn't have to go get the full distribution for 30 days, plug it in the calculator, and then have it calculate the mean or add those numbers, we could just use this formula. Okay, a lot better. I wouldn't want to do 30 calculations just so I could get one number. Okay, the variance, again, this is sort of the in-between one. We end up taking the square root of 7.4, and that gives us our standard deviation of 2.7. Okay, and again, the two that we're going to be looking at as important are the mean and the standard deviation. So if you just want to kind of have these in your notes, this formula here and this for the mean. Okay, that was like a whole day's of instruction. Okay, so that's all we got to be able to do is that. But I wanted to take you through that example to show you this works, right? We could do all the calculations, or we could just use these simple formulas, more simple formulas. But again, don't try to memorize it all because each distribution is a little different. If you're like me, I'll remember it, but I might apply it to the wrong distribution because by the time we're done, we'll have multiple different things that apply to different things. And every time I've taken a statistics class, the professors have always allowed us as students to have a page of notes because that's really what you need for statistics. When I was doing my research to get my doctorate, same type of thing. We could always, whenever, even when we went in for interviews, they let us bring in some notes because how the formulas are set up and stuff, you just can't remember it all, especially if you get stressed and stuff like I do, especially on an interview. Okay, so that finishes us up. Let me stop. It was 20 minutes.